Did you know that the simple act of tying shoelaces can reveal profound mathematical patterns? These patterns have fascinated mathematicians for centuries, and yet they remain largely unknown to the general public. So, let's explore the intricate world of shoelaces and uncover the secrets they hold. From the Fibonacci sequence to fractals, we'll delve into the mathematical wonders that lie beneath the surface of this everyday activity. But before we begin, let's take a closer look at what makes shoelaces so special. A typical shoelace consists of two long pieces of string or material with a series of holes or knots. When tied, these laces create a complex pattern of loops and twists that seem to defy logic. However, it's precisely this complexity that holds the key to understanding some of the most fundamental mathematical concepts. So, let's imagine we're mathematicians, and we're tasked with unraveling the mysteries of the shoelace. We'll start by examining the pattern of knots and loops, and how they relate to the Fibonacci sequence. The Fibonacci sequence is a series of numbers in which each number is the sum of the two preceding numbers, 1, 1, 2, 3, 5, 8, 13, and so on. As we tie our shoelaces, we create a pattern of knots that mirrors this sequence. Each knot represents a new number in the sequence, with the number of twists and turns determining its value. But that's not the strangest part. The pattern of knots also reveals a deeper connection to fractals. Fractals are geometric shapes that repeat at different scales, creating a self-similar pattern. In the case of shoelaces, the pattern of knots and loops creates a fractal that repeats at every level. This means that the same pattern of knots and twists is repeated at every scale, from the individual knots to the entire lace. And then something unexpected happened. We discovered that the pattern of shoelaces is also related to the golden ratio. The golden ratio is a mathematical constant approximately equal to 1/618, which has unique properties that make it appear in many natural patterns. When we analyze the pattern of knots and loops, we find that it's based on the golden ratio, with each knot representing a smaller or larger version of the ratio. This connection to the golden ratio reveals a deeper understanding of the mathematical principles underlying the shoelace. But how does this relate to real-world consequences? The understanding of mathematical patterns in shoelaces has led to breakthroughs in fields such as materials science and engineering. For example, researchers have used the principles of fractals and the golden ratio to design more efficient materials and structures. This has led to innovations in fields such as aerospace engineering and biomedical research. So, what does this mean for us? It means that the simple act of tying shoelaces can reveal profound mathematical patterns that have real-world consequences. It means that we can use these patterns to design more efficient materials and structures, leading to breakthroughs in various fields. And it means that we can appreciate the beauty and complexity of mathematics in even the most everyday activities. So, the next time you tie your shoelaces, remember the intricate mathematical patterns that lie beneath the surface. You might just find yourself seeing the world in a whole new light. Want to explore more mind-blowing facts about mathematics in everyday life? Subscribe to our channel for more incredible stories like this, and let us know in the comments what fascinates you most about the intersection of math and reality. Want to explore more mind-blowing facts about mathematics in everyday life?